So this video is going to look at how we can use the very strong recoil properties in dynamic tape to create a compressive force. Now that compression can be used to augment the force closure mechanism, whereby we're creating compression at the articular surfaces and therefore increasing that coefficient of friction to aid in force transfer and stability. Now, the dynamic tape has very strong recoil properties which allow this to be possible, unlike a kinesiology tape or a rigid athletic tape, or even some of the four-way stretching nylon kinesiology tapes. Now you'll see here we're using a power band, which is a double layer of dynamic tape, which we often do for some of our ligamentous or joint applications. And even on just one side, you'll see we're going to get a force back in this mediolateral direction. And you'll see, just because we're in that short position, the tape recoils and we're getting 42 newtons of force, about 4.2 kilograms of force. If we come from both sides to create that full circumferential application, now we're getting 64 newtons of force, about 6.5 kilograms of force. Now, if you try pressing on an algometer to create 64 newtons of force, you'll feel you really have to put a lot of force into that. We know from some of the work of Vleeming et al. Looking at the sacroiliac joint that 50 newtons of force was sufficient to create significant changes in stiffness or in pelvic motion at the sacroiliac joint, and actually increases beyond that didn't really make any substantial gains in stiffness or reductions in motion. So we can use this in a number of ways. Certainly if we're going circumferentially, we end up with a mediolateral sort of force and an AP force, so we're getting this biplanar compression, but many of our applications will also come under the foot and up, which gives us this cranial direction or this cephalad direction, so we get this triplanar forces going through there. We can also use the tape for things like our arch supports, where we're creating this force from the big toe back to the heel. That not only raises the arch, but it also compresses through those tarsal joints and therefore aids in that stability through that force closure mechanism once again. Importantly, it still allows the foot to move, so it can accommodate to the ground surface, can dissipate load through allowing some movement, but it decelerates that movement to absorb some of that load externally, and it still allows function by allowing or permitting full range of motion.